Today we're going to go over significant figures. Let's say we had some number like 234. Any non-zero digit will be counted. So this number has 3 significant figures. Likewise, if we had some number like 52, there are 2 non-zero digits. So this number has 2 significant figures. Now, what if we had a 0 in there somewhere? Let's say we had the number 802. Any 0 that's between 2 non-zero digits will be counted. So this number has 3 significant figures. Likewise, if we had a number like 2006, this would have 4 significant figures. What if there are zeros at the end of a number? For example, the number 400 has these 2 trailing zeros. In significant figures, we only count trailing zeros if there is a decimal point in the number. For this first 400 without a decimal place, it would only have 1 significant figure. On the other hand, since the second 400 has a decimal place, then this 400 has 3 significant figures. If there are trailing zeros after the decimal place, those get counted too. So 400.00 would have 5 significant figures. Now let's talk about decimal places. Say we had a number like 0.0071. This number has 3 leading zeros. In decimals, we do not count the leading zeros. So 0.0071 has 2 significant figures. For decimal numbers, though, it's important to remember that if the numbers before the decimal place are not 0, for example, if we had 2.0071, then you count everything. So 2.0071 would have 5 significant figures. It's only when the decimal starts with the 0 that these first zeros are leading zeros. Let's look at another decimal example. What if we had leading zeros, some non-zero digits, and then some trailing zeros? In this case, we would ignore the leading zeros because they don't count and start counting from the first non-zero digit. So this number has 5 significant figures. And we count these trailing zeros because they are after a decimal place. Let's do some examples. Here I have a couple numbers for you to figure out the number of significant figures for. Feel free to pause the video and try them out before I reveal the answers in 3, 2, 1. For the first one, 59,040 would have 4 significant figures because we count all the non-zero digits and any zeros between them and ignore this trailing 0. For 0.0640, we ignore the leading zeros and start counting from after the first non-zero digit. So this number has 3 significant figures. 55.9 is pretty straightforward because all of the digits are non-zero, so we count all of them and get 3 significant figures. 4.0000 will have us count all of the trailing zeros because they have a decimal point in there somewhere. So this number has 6 significant figures. And lastly, 4,500 will only have 2 significant figures because we do not count the trailing zeros since there is no decimal place. Now let's talk about rounding. Sometimes we will measure things but then have to round them to a certain number of significant figures. Or a math problem is asking us to round the answer to a certain number of significant figures to avoid too many digits. So let's say we were measuring something and it came out to be 576 milliliters. How would we round this to two significant figures? Well, we would look at these first two digits, and then for this last digit, we need to know if we want to round it up or down. So we look at the digit before it. Since 6 is higher than 5, we would round the 7 up to an 8. So 576 milliliters converted into two significant figures would be 580 milliliters. Now let's talk about multiplying and dividing significant figures. Let's say we had 4.23 times 2.1. How do we do this? First, let's find the unrounded answer by typing into our calculator, and we get 8.883. To round the answer to the right number of significant figures, we need to see which of the two numbers has the least number of significant figures. In this case, is 2.1, since 2.1 has two significant figures, while 4.23 has 3. So we want to round the final answer to two significant figures. We want to keep the first 8 and then look at the next digit after the second 8 and see if we want to round up or down. This 8 is bigger than 5, so we want to round up. So our final answer is 8.9. Let's do a couple of other examples. Let's do 3.68 times 9.4. And let's also try a division problem. 44.98 divided by 6.73. See if you can try them out on your own before I reveal the answers in 3, 2, 1. Let's type the first problem into our calculator, which will give us the answer of 34.592. Then we look at which of the two numbers has the least number of significant figures, which is 9.4 with two significant figures. So we round the final answer to two significant figures, and we get 35. Just a quick note, 35 and 35 with a decimal place would both have two significant figures. So technically, you could put either one as your answer. But since 35 itself is a little more straightforward and there's no zeros to account for, having that decimal place is a little useless, so I would just go with plain old 35. For the division problem, let's do the same thing. Type it into our calculator to get the unrounded answer of 6.68350,669. And then we look at which of the two numbers has the least number of significant figures. In this case, it's 6.73, which has 3 significant figures. So we round the final answer to have the same number of significant figures. So in this case, the final answer would be 6.68. Now let's talk about addition and subtraction. Let's say we wanted to add 50.09 plus 2.4. To determine the significant figures of the final answer, we want to look at the number between these two that has the least number of digits to the right of the decimal place. In this case, the winner is 2.4 since it only has one decimal place. So we know that our answer will only have one decimal place. A nice little tip that I got from the organic chemistry tutor, shout out to his very helpful videos, is that you can put this little line where the number that has the least decimal digits ends. So in this case, after the 2.4. And it can help remind you where to round your final answer to. Now we add the digits like normal and get 52.49. In this case, the number just after the cutoff, 9, is bigger than 5, so we have to round this 4 up. So the final answer is 52.5. Subtraction is the same story. Let's say we had 8.54 minus 0.653. In this case, the number with less digits to the right of its decimal is 8.54. So we can put a line after that to signify that we will cut off our final answer to have only 2 decimal places. Then we can subtract like normal. We bring over a 1 to make 10 minus 3 is 7. Bring over a 1 to make 13 minus 5, which is 8. Bring over a 1 to make 14 minus 6, which is 8. And 7 minus 0 is 7. And then since the digit that we cut off at is bigger than 5, we round up. So our final answer is 7.89. Thanks for watching. I hope that you found this video helpful.